Gold has been a symbol of wealth, power, and beauty since ancient times, capturing imagination and admiration of people around the world. But have you ever wondered how that shiny, 99% pure gold bar is made? The journey from raw rock to a gleaming gold bar is a fascinating process, full of careful steps and attention to detail. From the moment the gold ore is extracted from the earth, it undergoes a series of transformations. Skilled workers and advanced machinery work hand in hand to refine, melt, and mold the precious metal into the bars we see in banks and vaults. So what is the secret behind making such pure gold? How do miners and craftsmen ensure each bar is as pure and high quality as possible? Let's find out. When we talk about the production of pure gold bars, the process is both fascinating and complex. It all starts with mining and extraction. First, the gold needs to be located and extracted from the earth. In the past, hydraulic mining used high-pressure water jets to separate gold from deposits. Today, more advanced methods like explosives and various mining techniques are employed. There are 4 common methods to mine precious metals: placer, hard rock, byproduct, and ore processing. Placer mining is popular among amateur miners and uses methods like metal detection, dredging, panning, sluicing, and cradling. Relies on water and gravity to separate gold from other materials. Hard rock mining involves extracting gold from rocks through open wells or underground tunnels, and it remains the most widely used method globally. Byproduct mining is similar to hard rock mining, but focuses on extracting other materials like copper, gravel, or sand, with gold being a secondary product. This method can be quite profitable due to the significant quantities of gold and silver obtained. Ore processing, while less common due to its high cost and environmental impact, involves crushing rocks containing traces of gold and using chemicals like cyanide to extract the metal. Once the gold has been mined from the earth, it is sent to a refinery for further purification. The journey from raw ore to pure gold bars is an intricate process that transforms rough rocks into gleaming treasures. The initial step at the refinery involves crushing the gold ore into fine grains, increasing its surface area and making it easier to process. A chemical solution, usually cyanide, is then applied to the crushed ore in a process known as leaching. This solution dissolves the gold, which is then separated from the other minerals. The mixture is heated in a smelter to around 1600 degrees Celsius, 2912 degrees Fahrenheit, causing the gold to sink to the bottom while impurities float to the top as slag. Following this, the gold undergoes further refining to achieve high purity levels. 2 common methods are the Miller process and the Wall-Will process. The Miller process uses chlorine gas to remove impurities, producing gold that is about 99.5% pure. The Wall-Will process, on the other hand, uses electrolysis to refine gold to 99.99% purity. This high level of purity makes the gold suitable for various applications, including jewelry, electronics, and investments. Modern gold mining operations are highly automated, using advanced technology to enhance efficiency and safety. Equipment like excavators, trucks, and drills are often controlled remotely from a central location. Safety features such as automated monitoring systems and emergency response plans are in place to minimize the risks of accidents. Additionally, strict environmental regulations ensure that mining activities have minimal impact on the surrounding ecosystem. Hey, if you're enjoying the video so far, make sure to like and subscribe to our channel. It really helps us out a lot. When the gold is ready for pouring, it's melted in a furnace at a temperature of around 1200 degrees Celsius to remove any remaining impurities. Substances like niter, borax, sand, and soda ash are added. These materials help keep the gold liquid and draw out impurities, which form on a layer of slag on top. The molten gold is then carefully poured into molds to form bars. As the gold cools and solidifies, it's monitored to ensure that it meets the desired purity levels. A sample is taken and sent to a lab for testing. Within a short time, the gold solidifies and is ready to be handled. The solid bars are removed from the molds, and any remaining slag is cleaned off, revealing the gleaming gold underneath. The slag is removed after the gold is melted, leaving behind a substance that is not gold but appears black, almost like obsidian. The slag removal is crucial to ensuring the purity of the gold. Once the molten gold is free of impurities, it's poured into molds to form bars. As the gold cools, it solidifies quickly, usually within a few minutes. Once cooled, it's safe to touch and handle. The solid gold bars are then removed from their molds and given a thorough cleaning to ensure they shine and meet quality standards. Some bars may appear less shiny if the gold came from low-grade ore, but they still maintain a high level of purity typically around 95%. Next, the gold bars undergo a finishing process. Any sharp edges are smoothed out, and small gold balls that may have formed are flattened to ensure they don't break off during transport. Each bar then stamped with a unique number for identification and recording purposes. This number tracks the production and authenticity of each gold bar, a practice that has been in place for years. Gold coins, on the other hand, are made through a minting process that includes several steps. After inspection, the coins might go through additional treatments to enhance their appearance and durability. Techniques like polishing, frosting, or applying special finishes like proof or matte finishes give the coins their distinctive look. These treatments ensure the coins are not only valuable, but also aesthetically pleasing. The finished gold coins are then placed in protective holders or capsules to preserve their condition. They're often packaged in tubes or presentation cases before being distributed to authorized dealers, collectors, or buyers. This careful packaging ensures that the coins remain in pristine condition until they reach their final owners. Gold is unique in that it can be reused and reprocessed without any loss in quality or purity. This exceptional property makes gold incredibly valuable, not just for its beauty and rarity, but also for its wide range of applications. For instance, gold nanoparticles exhibit remarkable properties like high conductivity and surface plasmon resonance at the nanoscale, making them indispensable in fields such as electronics, catalysis, medical diagnostics, and targeted drug delivery. One of gold's most fascinating attributes is its malleability. A single ounce of gold can be hammered into a sheet covering about 9 square meters, known as gold leaf. This extreme malleability is why gold has been used for centuries in art and architecture, allowing artisans to create intricate and detailed designs. However, pure gold is quite soft, which limits its use in some applications. To overcome this, gold is often alloyed with other metals to enhance its strength and durability. In ancient times, a naturally occurring alloy of gold and silver, called electrum, was used for jewelry and currency. Today, different alloys are used to create more durable gold items, from jewelry to coins. Gold's high melting point, approximately 1064 degrees Celsius, along with its excellent heat and electrical conductivity, makes it valuable in industrial applications such as electronics and aerospace. Gold plating is a common technique used in electronics to apply a thin coating of gold to connectors and circuitry, providing excellent conductivity and resistance to corrosion. In medicine and dentistry, gold is used for its biocompatibility and resistance to corrosion. Dental restorations like crowns and bridges often use gold. Additionally, gold nanoparticles play a crucial role in diagnostic imaging techniques, helping to advance medical research and treatment. Globally, the top gold producer countries include China, Australia, Russia, the United States, and Canada. These nations have significant mining operations that contribute substantially to the global gold supply. The production and recycling of gold involves a series of meticulous processes that ensure that the metal retains its high value and purity. The gold recycling process is a testament to gold's sustainability. It involves collecting materials containing gold, such as electronic waste, old jewelry, or industrial byproducts, and then sorting them based on their gold content. These materials are then processed to extract and purify the gold, ensuring that none of this precious metal goes to waste. Next is the dismantling and pre-processing phase, which is crucial for handling electronic waste. Here, electronic items are taken apart to separate components like circuit boards, connectors, and other parts containing gold. These components are set aside for further processing. When it comes to old jewelry or gold-bearing scrap, the items are often pre-processed by sorting, cleaning, and removing non-gold materials, such as stones or other alloys. Gold is often considered a sound investment for several reasons. Firstly, it serves as a reliable store of value. Throughout history, gold has been recognized as a valuable asset, maintaining its worth over time. Its scarcity and desirability contribute to its long-term preservation of purchasing power, making it a favorite asset among investors. Secondly, gold acts as a hedge against inflation. When the value of fiat currencies decline due to inflationary pressures, gold tends to retain its value or even appreciate. Investors often turn to gold to protect their wealth during times of rising inflation, providing a sense of security in their investment portfolios. Including gold in an investment portfolio offers diversification benefits. Gold's performance typically has a low correlation with other assets, such as stocks and bonds. This means that when other financial assets experience volatility or decline, gold may act as a counterbalance, potentially reducing overall portfolio risk. Gold is also considered a safe haven asset during times of economic uncertainty or geopolitical turmoil. Investors turn to gold as a form of protection when they perceive increased risk and other investment opportunities. Its historical role as a safe haven has been demonstrated during market downturns and financial crises, further solidifying its reputation. One of the significant advantages of gold is its liquidity. Gold can be easily bought and sold in various forms, including physical gold, gold-backed exchange-traded funds, ETFs, or gold future contracts. The global gold market is deep and active, allowing investors to enter or exit their positions with relative ease. Gold can act as insurance within an investment portfolio. Its value often rises during times of financial market stress or when other assets underperform. By including gold in a diversified portfolio, investors can potentially reduce losses and enhance overall risk-adjusted returns. Gold's unique properties, such as its high conductivity, resistance to corrosion, and malleability, make it invaluable in various industries. In electronics, gold is used as connectors and circuitry due to its excellent conductivity. In aerospace, gold-coated components ensure reliable performance under extreme conditions. In medicine and dentistry, gold's biocompatibility and resistance to corrosion make it ideal for dental restorations and medical diagnostics. Recycling gold is an efficient and sustainable way to manage this precious resource. The gold recycling process involves collecting materials containing gold, dismantling electronic waste, and pre-processing jewelry and scrap. The materials then undergo size reduction and shredding to facilitate the release of gold particles. Various extraction methods, such as chemical extraction, mechanical separation, and electrolyses, are used to recover gold. The resulting solution or slurry is filtered and refined to remove impurities, ensuring the recycled gold meets high purity standards. In modern gold refining, advanced technologies and techniques have significantly improved efficiency and safety. Automated systems control heavy machinery, such as excavators, trucks, and drills. These systems are often managed remotely from central control rooms, reducing the need for manual labor in hazardous conditions. Safety features like automated monitoring and emergency response plans further minimize the risk of accidents, ensuring a safer work environment for miners and refinery workers. Environmental concerns surrounding gold production are significant and multifaceted, reflecting the balance between extracting a precious resource and safeguarding our planet's health. One of the primary environmental issues is habitat disruption and biodiversity loss caused by mining activities. When forests are cleared and ecosystems disrupted to access these gold deposits, it can lead to the displacement of wildlife and loss of crucial biodiversity. This disruption can have long-lasting effects on local ecosystems, affecting everything from soil stability to water quality. Another major concern is water contamination. Gold mining often involves the use of chemicals like cyanide and mercury to extract gold from ore. These chemicals can leach into nearby water sources, contaminating freshwater ecosystems and posing risks to aquatic life and human health. Efforts to mitigate this impact include strict regulations on chemical use, as well as technologies like cyanide destruction processes to minimize environmental harm. Additionally, the energy-intensive nature of gold processing contributes to greenhouse gas emissions and climate change. The extraction, transportation, and refining processes all require significant energy inputs, primarily from fossil fuels. Reducing the carbon footprint of gold mining operations is crucial for mitigating climate impacts. Innovations in renewable energy use and energy efficiency are being explored to lessen the environmental footprint of gold production. The legacy of mining operations also include the challenge of managing mine tailings, which are the leftover materials after the extraction of gold from ore. These tailings often contain residual chemicals and can pose risks of contaminating soil and water if not properly managed. Modern practices aim to secure and stabilize tailings to prevent environmental damages and potential health hazards to nearby communities. Reclamation and rehabilitation efforts play a vital role in mitigating environmental impacts. Responsible mining companies engage in reforestation, habitat restoration, and land rehabilitation to restore ecosystems affected by mining activities. These efforts not only mitigate environmental damage, but also support local communities by restoring natural resources and enhancing biodiversity. Public awareness and advocacy for sustainable mining practices are essential in addressing these environmental concerns. By promoting transparency, accountability, and innovation in the gold mining industry, stakeholders can work towards minimizing environmental impacts while ensuring the responsible extraction and use of this valuable resource. So, what do you think of the journey of gold, from mining to refining and recycling? Share your thoughts down in the comment section below. If you enjoyed watching this video, make sure to like and subscribe for more videos like this one. Thank you for watching, and we'll see you in the next one.